What's happening, y'all? Welcome back. In this video, we're going to continue our discussion of combining logical operations together by looking at some popular combinations that actually don't have hard-coded functions or built-in functions in MATLAB. Let's jump right in. We're going to start with something called a NAND operation, which means not and. I read that as NAND. This operation is actually pretty powerful in computer science. We're not going to spend a ton of time talking about it today, but I want to show you that we can use a combination of not and in MATLAB to code this up formally. So remember that the AND operation is true exactly when both inputs are true. We saw the truth table of that looks like this on screen. 0, 0, 0, 1. The 1 happens only when the two inputs evaluate as true. NAND means not and. In other words, we take this output 0, 0, 0, 1 and we hit it with a not operation. Remember, not turns trues to false and false to trues. In other words, zeros turn to 1 and 1 turn to 0. We invert each of those bits. So NAND would be true exactly when and is false, and that's what we see up here. Not P and Q is the equivalent of NAND or not and, which is 1, 1, 1, 0, because 0, 0, 0, 1 knotted would be 1, 1, 1, 0. In MATLAB, we can get that by combining operations together, as we've seen in previous videos. Let's define P to be the logical column vector, and we'll say that this is 0, 0, 1, 1. We'll also define Q to be the appropriate column vector, so this is 0, 1, 0, 1 when I push enter. Remember, P and Q takes the and of those two things, which is exactly what we expect in the truth table. I could try not P and Q, but remember we had a video on operator precedence. In this case, what MATLAB has done is took not P and Q. So the better way to write that in the way that MATLAB interpreted it looks like this, but that's not the NAND operation. That's not P and Q. In order to get the NAND operation, what we're going to do is strategic use of parentheses. So I'm going to say not and. Well, remember, not and is 1, 1, 1, 0. That's exactly what I get when I combined and the parentheses themselves, and then outside of that, the not operators. So I would read that command as not and, or NAND P and Q. In a similar spirit, we can define a NOR operation, which is not or. Remember that the OR operation is true exactly when at least one of the inputs is true. So that leads to an output of 0, 1, 1, 1 in this truth table. NOR means not or. So in other words, we're going to invert each of these things. So 0, 1, 1, 1 inverted becomes 1, 0, 0, 0. We can get that by actually combining these together. So remember, P or Q is logical OR, so in other words, P inclusive OR Q. If I want to do the NOR operation, I put not P or Q. When I push enter on that, notice that I get the exact output for my NOR truth table. We do have to be careful in terms of operator precedence. If I do not include the parentheses, MATLAB is going to do not P or Q, which is why the truth table output of that operation is not what we expect for the NOR operator, because I didn't take advantage of my operator precedence rules as I should have. The last specialized operation we're going to do by combining operators together is something called the XNOR operator. It really should be called the NXOR operator, because this means not exclusive OR, but do you see how the XNOR kind of rolls off the tongue better than not XOR? So anytime you hear XNOR operator, what we mean is not XOR, so the negation of the XOR operator. Remember, XOR is true when exactly one of the inputs is true. That leads to the output of a truth table as 0, 1, 1, 0. To do the XNOR operator, I'm going to take the not of that output. So 0, 1, 1, 0 would be inverted to become 1, 0, 0, 1. Let's go ahead and check. If I take P XOR Q, remember that we get this output 0, 1, 1, 0, and then the claim is we're actually going to take the not of that. So specifically, we're going to input that to the not function, or we could, of course, also take the output of XNOR and hit it with the not operator. Both of us give us the XNOR operation, which is the not XOR. I do want to show something kind of fun here. These operations, so we start with two inputs. We have P and Q. We run through all possible combinations of both of those. And then we have a set of binary operations that we've gone through in these videos: and, or, XOR, NAND, NOR, XNOR. We can actually make this table in MATLAB and lay out these different logical operations. Let's go ahead and do that. First column is going to give P, second column is Q. Let's do the third column, not P, and we'll do the fourth column, not Q. Then what we'll do is we'll say P and Q is going to be column 5, P or Q is column 6. Then we'll do X or P, Q. Then column 7, we're going to take not and. So remember that is not P and Q. Column 8 is going to capture P nor Q. So that's not P or Q. And then column 9 is going to do P, X nor Q. So that's not X or P, Q. When I push enter, notice that matrix on screen actually matches the truth table for all these different combinations. This actually goes quite deep into computer science. There's something called logic gates, which map back to transistor level design. This is actually kind of the heart of computer architecture in terms of the logical structure. I'm not going to go deep into this. I just wanted to show you some of the functionality in MATLAB and how we can recreate these logical operations. We will also use these operations as part of the conditions for if-else statements in MATLAB, which is why we went through the trouble of developing all this. With that, we're almost done exploring logical operations in MATLAB. Remember, this relates to our larger discussion of the logical data class. This was one of the 16 fundamental data types in MATLAB. In a previous video, we said that there were really 4 purposes of using logical data in MATLAB. Those were to perform logical operations, to perform relational operations, to test the state of MATLAB variables, and to address or find special entries of arrays in MATLAB. In this case, we have just covered a bunch of logical operations and how those work in MATLAB. This is a programming structure to be able to write code that allows us to do one thing if something is true and some other thing if something is false. In other words, to branch our code into 2 different sections, one of which evaluates in the case of trueness, the other one evaluates in the case of falseness. This is called a branching statement. In MATLAB, a very, very common one is called an if statement. We also have a case statement and also a switch statement that allow us to really take advantage of these structures. We're going to do just one more video on logical operations. Then we're going to move on to figuring out how to do these other 3 situations. Hopefully you're noticing how nuanced this particular data class is and how powerful it is in terms of testing statements in MATLAB. That leads us into our community challenge of today. In the comment section below, please post your ideas about how NAND, NOR, and XNOR operations show up in applications. Those are rich subjects. You can write your own ideas or provide links to authors that have good insights into those logical operations. I always welcome your questions, comments, concerns, and feedback. When you give me feedback, my brain grows bigger. Thank you so much for your attention. I'll see you in the next video.